Hello, 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 hello. Okay, today what we're going to do is we're going to talk about logarithm properties. So first, one of the key things we want to do is we want to remember the definition of a logarithm. You got to remember that the definition of a logarithm is what we use most of the time. So if we can remember that log base b of x equals y, that's true if and only if the base to the answer power equals the of number. So remember, this base being a half line lower is a very important fact to recognize. Okay, so this is log base b of x equals y, and that's true if and only if the base to the answer power equals the of number, or b to the y equals x. Next, remember that a common log, the one that you see in your calculator, log, is simply a log base 10. And so with those two things, what we can do now is we can move on to the product property. So most of the time we use the definition of a logarithm. Eventually we'll learn the change of base formula so we can use our calculator to do any base with the common log. But for right now, let's take a look at the product property. What the product property tells us is that if we have a log base b of something multiplied, like m times n, what that's going to do is that's going to break apart into two logs of the same base of the first part plus log of the same base of the second part. And that's your product property. Notice it's called the product property because right there is your product. So basically what you can do is you can change the product of a logarithm into the addition of two logarithms with the same base. The quotient property is the same idea. It's the one where we have log base b of a division. Let's say m over n. What that's going to do is it's going to break apart in the same way into two logarithms, but instead of using addition, we're going to change this into the log base b of m minus log base b, same base, of n. So notice here, the numerator is always the first part. The denominator is subtracted from the numerator part. And notice it is two logs. It's not a single log. Finally, we have the power property. And the power property is the one where if we have something like log base b of m to the x power, now that power comes to the front as a multiplier. So we'd have x times the log base b of m. So in other words, what this one is this is really a funky version of the product property. Because realize m to the x power is just x number of times that you would multiply m. So you could think of that as m times m times m, however many times, and that would break apart into the same thing being added multiple times, because it would still be m here and here. If you're adding the same thing multiple times, that's where we get the idea of multiplication from. So that's why it would be x times that logarithm amount. So there are your properties. Let's go ahead and give it a try here and see what we get. Let's do an example problem. So let's take a look at something like 3 squared equals 9. Well, let's write that as a logarithm. To write that using the definition of logarithm, we would say log base 3 of 9 equals 2. And that's just rewriting an exponential as a logarithm. Okay? We can do the same thing, go in the other direction. Let's do something with the variable here. Let's say, what if we have common log of x equals 4? Well, what does that mean? Well, what that really means is common log, remember, that's log base what? Right, that's log base 10. So what we really get here is 10 to the 4th power equals x. And that we can actually solve. You get 10,000 there. Okay? So, that's that one. Let's take a look at a product property example. So let's start with log base 2 of 4 times 3. Well, that's just 12, but if it said 12, we could break it into 4 times 3. We could even break it into 2 times 2 times 3, couldn't we? So let's leave it as 4, and you'll see why in a minute. So that's going to turn into log base 2 of 4 plus log base 2 of 3. Now you might think we would end there, but log base 2 of 4, you'll notice, that's one we can actually do in our head. 2 to what power equals 4? Remember, back to here, the base to the answer power equals this number. So you're saying 2 to what power, 2 to y equals x. 2 to what power is 4? Well, 2 to the second power equals 4. So we can really finalize this as 2 plus the log base 2 of 3. And we would finish there. Now, let's go ahead and try one with a quotient property, but let's use a variable with this one. And instead of breaking it apart, let's put it together. So let's say, what if we had, let's get a different color here. Let's go there. What if we had log base 3 of 5 minus log base 3 of x? Now in this case, we would be combining. Here, we're expanding. In this case, we're now combining. And so since it's subtraction, I've got this right here. I'm not looking at this one. I'm looking at this. It's going to combine into division. And my first term is the numerator. My second term is the denominator. Even though it's got a variable, we can still simplify this. Log base 3 of 5 over x. We end up with that. So finally, let's try a power property problem. Let's go back to black there, and let's do something like this. Let's say we've got, oh gosh, I don't know, 3 log base 4 of x. Now, how could we rewrite that? We could basically expand it, because right now it's condensed. Actually, no, it's expanded. We're going to condense this by bringing this multiplier up as a power right there. So here we would change this to log base 4 of x cubed. And that would be the simplified version. So it doesn't matter if there are variables, doesn't matter if it's all whole numbers. If you can simplify whole numbers, feel free to do so. There are your basic logarithm properties, folks. Hope this helps, and have yourselves a good day. Happy thinking.